Hello and good morning. My name is Rob Ralston. I'm a Senior Business Development Manager here at XTIVIA. Thank you for taking the time today to join us for our MuleSoft Runtime Fabric webinar. We are very excited to demonstrate using Runtime Fabric on AWS. Following the demo, we'll have a panel Q&A session with three of our senior architects from our MuleSoft practice. Shrikant, an application architect, Rajeshri, an application architect, and Manny, a MuleSoft integration architect. With that, Shrikant.
Thank you, Robert. Anypoint Runtime Fabric is a container service as it automates and orchestrates your deployments of Mule applications on private cloud or a corporate data center. Actually, the Runtime Fabric is the best way for the customers needing to deploy on-premise, being own cloud benefits to your private cloud. This is the basic advantage. And if you see this, these are the capabilities of Runtime Fabric. You can deploy multiple versions alongside in the Runtime Fabric, as well as it provides a 99.99 SLA. It provides a zero downtime, and you can horizontally and vertically scale the application using increasing the number of cores, as well as you can add as many as nodes you want. Also, we have automated failover option that we are going to see in the installation step. Runtime Fabric is, as we said, it is to provide a container service. Inbuilt, it is going to have a Docker and Kubernetes. So it is going to provide out-of-box Kubernetes management console in order to view how many parts it's got created, as well as what's internally happening, what logging is maintaining by Kubernetes. Everything you can see from the out-of-box portal. And it is an infrastructure agnostic. It can be deployed into AWS or Azure or any on-premise data center bare metal servers. So this is a typical architecture for our Runtime Fabric. If you see, the minimum requirement for production is the 3 controllers and 3 worker nodes. So each node has to be assigned in a different availability zone in order to provide, in case of failover, we are going to provide high availability. That's the reason we are going to keep in different availability zone. And controller can be ranging from 3 to 5. The 5 is the max, and 3 is the least for production. Whereas workers nodes, which can be ranging from 3 to 16, based on the application load we have to distribute, and we have to assign these particular workers. And as we just discussed, the Runtime Fabric will maintain different Mule runtime versions. Like in the same infrastructure, you can maintain Mule 4.1.4, as well as we can maintain Mule 3.9.2. So like this, we can leverage the existing infrastructure for our complete enterprise Mule environments. This is the basic data flow, how data flow is happening, and how the agent will sit on the controller node and what agent is going to do. This will depict. So TCP load balancer is an external load balancer on top of controller nodes. It will be kept it as a layer 4 layer. So it will distribute the load from whatever the received from the client using web browser. So that load will distribute based on the available active controller node. It will send, and that's it. And each controller node internally, it's going to maintain a separate internal load balancer that will take care about how the load will be distributed to different worker nodes. This is a Runtime Fabric network architectural diagram. So as soon as we get the request from a client browser using HTTPS, that request will route to the external load balancer, that is which is in the step number 2. The request will receive using a web application firewall. It is in layer 7. So in order to secure our site, we are going to enable cross-site scripting and SQL injection. These different properties we are going to enable for this user request. So once we pass with that particular all rules, so the request will reach to the TCP external load balancer, that will route to the internal load balancer. From there, the request will direct to the active worker nodes based on the different algorithm mechanisms. So there are two different types of algorithms: dedicated node and shared node. So dedicated node will be all request whatever like previously received, that particular, based on that particular session information, it's going to the corresponding node only instead of sending to the different nodes. So this is basically based on our configuration of the algorithm. On that basis, it's going to route. So in the similarly, as once the worker node provides the response, and the response will send back to the HTTP client. Runtime management, for managing this one, there is an operation center for Runtime Fabric, which is provides, we call it as an operation center, op center. This will enables the end users to watch the logs, what's happening in the complete applications, as well as Kubernetes, and we can see if any errors from the logging module, and we can see the metrics, what is the CPU and memory utilization using this op center, as well as Kubernetes is embedded in this Runtime Fabric. We can see number of pods and its ID, and what is the memory utilization, everything from you can control from the operations center. Whereas if we go into see into the Runtime Manager, Runtime Fabric configuration module, it is out of box provided by Runtime Fabric. With that screen, we can able to deploy and monitor, and we can secure our applications in Runtime Fabric. In the demonstration, we are going to see this in detail. So in order to go ahead with the installation, there are a prerequisite. First, we need to obtain the license for the customer, need to have a Runtime Fabric enabled software license. So it's basically will be available for platinum customers. So that is a step number one. And two, we have to create a Runtime Fabric, and we have to follow different steps to set it up. There are three different approaches. One is manual approach, where you can set it up in our corporate data center bare metal servers or any private clouds, whereas the public clouds, where like AWS and Azure is providing automated scripts. For AWS, it's supporting by Terraform. Terraform is an infrastructure automation tool, these days much popular. So using that, we can set it up in a 10 to 15 minutes our Runtime Fabric. Whereas Azure, there is a customized templates to create a customized infrastructure. Using that customized templates which are provided by Runtime Fabric, we can set it up. For this demonstration, we are going to use AWS using Terraform. That is what we are going to show in the installation. The last step is we have to enable the inbound traffic. So we need to provide a valid SSL certificate in order to access this, and you have to enable the traffic. Then only the request will be served by the Runtime Fabric. So for this, as we said, we are going to select the AWS for this one, and we need to have the prerequisites. We need to have AWS credentials and a Mule license file, as well as we need to provide number of workers and controllers. These are the prerequisite items. So I'm going back to my installation step of this one. First, in my command prompt, I need to check for the AWS version. So this is the AWS version I'm using. In order to do this, we need to install AWS CLI. So command line interface we have to install in order to talk to our AWS account. For that, we need to first, from the command prompt, you have to configure the AWS, which is you need to provide AWS key, access key, and secret key. These are available from our AWS portal. These keys will refer to the account where you want to install our infrastructure. So after that, you need to specify the region, which region you would like to install this one. That is US East 1, and followed by what is the output format. I'm keeping JSON. That's it. So we are good to go ahead with. So before that, we need to also install the Terraform. I already configured the Terraform. Just you can make sure you can check it out. Okay, this is the version we have already installed. After this, we have to go back to our Anypoint Management Center. In this, go to Runtime Fabrics. So on this, we have to create a new Runtime Fabric. I have just created, and here we have provided it will be provided a list of files in a zip format for AWS, Azure, and for automated scripts for manual deployment. So if this complete bundle I have downloaded, and it is available on my desktop. So if you see, these are the files I want to install in the AWS. So before that, these all are prerequisites already provided by default provided by our Runtime Fabric. So this is a file I have explicitly created. In this file, I'm going to pass the runtime parameters. So what are the parameters doing? And you want to provide is, the first one is cluster name. This is a user defined name where you would like to see in the cluster what is the name of it. And key pair is the one actually we have to create it in the AWS one in order to perform the SSH to the different worker and controller nodes. We need to have a SSH key. That is the key. We call it as a key pair in AWS. So I have created like Runtime Fabric, and we have to make sure that this has to be created in the US East 1 region only, because our cluster is setting up in this environment. Upon the creation of this one, we have to specify that name itself, and you have to specify the controllers and workers. I am specifying control nodes 3 and worker nodes 3, and it will ask you, would you like to enable the public IPs? Yes. If you want to access publicly, you can keep it true, otherwise false. And the activation data, which will be provided by the MuleSoft during the Runtime Fabric creation. So if you go and in the step number 3, you can copy and you can paste it here. I did the same. And whereas the Mule license is the customer license file base64 encoding. So it's a very big lengthy file. So this is my base64 encoding for my Mule license file. That's it. These 7 parameters is sufficient in order to set up the cluster. For this, we have to go to that particular location. Just trigger Terraform init. We are good to go ahead with the setup for our AWS Runtime Fabric installation. So we have to initialize this. So upon the successful initialization, we have to execute a Terraform plan. This Terraform plan will show you a simulation report for this AWS Runtime Fabric setup. What are the different VPCs it's going to create, how many subnets it's going to create, followed by how many EC2 instances. Everything it will simulate, and if any connectivity issues it found by Terraform tool, it's going to throw an error right away. So in the plan itself, we can able to find, is there any issues once we execute our Terraform. So this is how we can leverage this Terraform to set up our infrastructure with easy steps. So these are the scripts actually designed by MuleSoft Runtime Fabric team. So this just is going to show list of steps. So these many steps it's going to include. After this verification of this particular script, we have to execute Terraform apply. Apply will go ahead and start the installation of the cluster on AWS. So it will take some time. So what I'm going to do is I'm going to set it up. I'm going to have already set up the version of AWS Runtime Fabric. I'm going to show that. So if you see, there is in this plan, there are 47 items to add. So everything is plus in green means, so this all simulation report is successful. There is no issue with that. So just we need to execute Terraform apply -var file. The file which we have just now created, that file you have to specify like variables.tfvars. This is the statement we have to execute in order to set up the new cluster. So it will take 10 minutes to set up. So I'm going back and showing you the existing cluster setup. So if you see this, it has created 5 different EC2. In that, 3 are the controllers, 2 are the worker. I'm setting up a non-prod in an environment. That's the reason 2 workers is sufficient, but we have to ensure 3 controllers are the mandatory. So in that, the first controller will elect it as a master node, and these 2 masters are the secondary nodes. So if you want to see, and if you want to see the operation center, the operation center will active in the very first node. With the name itself, we can identify. So this is successfully set it up. If you want to go ahead and verify, you just have to, once we created, go to Runtime Fabric, backend, once the cluster is up, the status will change it as active. If you go to the active, it will show you the health report. Inbound traffic is enabled in this, and application status is healthy. And if you want to enable this inbound traffic, you can see how many replicas you want. And as we discussed, we have to configure a HTTPS inbound traffic. We need to set up a TLS. In order to do that, Runtime Fabric, you have to go to Secrets Manager. In MuleSoft, there is already existing option. In that, you have to upload your private keys and public keys. So for that, if you see, this is my key. I have uploaded my in a key store. This is the file. I created a using OpenSSL. There, I created a self-signed certificate for 1 year, and that's the reason this is expiring in 2021. And that's it. And I'm uploading the TLS context also. I have created the TLS context. Once we're done, we are just go ahead and finish this. So it will be ready for use in our runtime manager. So I'm going back to this one. On this runtime fabrics inbound traffic, if you go and select this particular environment, in this environment, it will populate you the secret groups and the TLS context. That's it. And if you see this certificate is registered on this, this is fully qualified name, runtimefabric.xtivia.com. For this DNS, I have associated this particular IP. So the request will directly, whatever on this DNS will route to this particular controller. From there, the cluster will start working. So if you click on OK and come back, so that's it. We are good to go ahead with the deployment of the Runtime Fabric. In order to do that, once this cluster is up and running, you have to go back to the applications and click on Deploy Application. And select the XTIVIA. This is the web Runtime Fabric. The above one is the Cloud Hub. If any local environment registered, that will be populated here. So we are going to deploy this into the Runtime Fabric, and you can upload a file where you can find it out, the Mule 4 archived file. So you can just upload into this one. So I am selecting this, and here is the interesting thing we have to select is how many replicas you want. So my workers is 2, max I can give 2. If my workers as much as it is reached to 6, you can give up to maximum 6 or 8. So I'm just giving 2, and 2 options: run runtime cluster or enforce the deployment replicas across nodes. So I'm in deploying in cluster mode. And you can associate the number of cores and number of CPUs. So that is the one option. And second one is recreate and rolling update. Rolling update without stopping the existing module, it will deploy. So there is no downtime. And coming back to this, all enable inbound traffic as this one. So it's enabling on this particular one. And if you have any properties, key value pair, suppose port is equals to 9090, something like that, if you can provide, and just deploy this application. That's it. So it will be good, and it will deploy into Runtime Fabric. So this is the one, it is taking time. So if you see this one existing application, we have deployed, and application, oh, it's applying still. So I'm going ahead and just showing this existing one. I created 2 replicas. So 2 out of the 2, it's 2 got started, and application available in this URL. We assign the DNS, and it is deploying in Runtime Fabric version 4.3.0. And that's it. It is now application status is running. So you just go ahead and click this particular URL. So it will show you here, no listener for endpoint. So this particular sample one is enabled and hello. So if you see, Mule 4 sample application successfully deployed into Runtime Fabric 1.6. So with this, we deployed a sample application into our newly created Runtime Fabric environment. This is how we can use and leverage our existing infrastructure for multiple Mule versions and with zero downtime. Hope this for helpful for the all customers in high level. Okay. In this, as we see, cluster has created like this, and we have seen what is the operation centers. So how these operation centers can be accessible, I'm going to show, and the deployment is done. And these are the high level benefits of the Runtime Fabric. The first one is automated failover, and we can perform the rolling deployments. As we see, it's a infrastructure agnostic and out of the box management console available for this Runtime Fabric. So on top of on-premise Cloud Hub, Runtime Fabric is providing much more powerful capabilities on this latest technology trends using Kubernetes and Docker. And lastly, I'm going to show before this one, how this our operations center is going to work it out. So this is the operation center where we can see the logs and Kubernetes, how many parts it got created. So that you can access from this particular URL. In case of any issues occurred in the cluster, so we can control and we can manage from this particular portal. If you see these many operations, we can perform adding a server and installing the cluster. Whatever the server currently active, it will show in this. And logs you can monitor in each node. So if you see, this is how how many transactions happening, we can see it here. If you see, there is a Kubernetes option in the left side. It's already ready immediately embedded into this particular operation center. If you go back to the pods and see how many pods created for my application. If you see, this is my new application, Runtime Fabric sample app. You can see here, each application will be having its own unique ID. So based on that ID, it will going to show this one. So this is how we can control. We are, if you have any questions further, please.
So thank you so much for joining us, everyone. My name is Alex Killian. I'm the video producer here on the marketing team. And I'm just going to help out a little bit with our Q&A section here. Rob, do you want to address this first question?
Sure. What happens if a redeployment of an existing running application fails?
The previous application remains active and it keeps running.
Awesome. Thank you. Another question. How is RTF different from Cloud Hub?
It is not actually MuleSoft hosted runtime. The infrastructure will be on the customer side.
Sweet. Thank you. Man, we got a bunch more questions coming in, Alex. Can we do clustering in RTF?
Yes, it is by default cluster enabled.
Okay. What are the minimum and maximum workers we can use in RTF and prod?
Minimum 3 and maximum of 16.
Oh, okay.
If you don't have that, then it will complain saying that it's not a prod environment.
Okay, thanks, man. Which of the below use the run the internal load balancer?
Controllers.
Okay. Thank
So
you.
what happens in controllers, like the controllers also can act as a load balancer. It's just a different type of node type.
Okay. Which is the minimum vCPU you can assign to an application in RTF?
So it can go all the way till 0.02. In Cloud Hub, you can do 0.1, but in Runtime Fabric, you can go much lower. You can go all the way till 0.02.
Okay.
So you get a higher application density with that.
Okay. Thank you, man. Alex, was there any other questions that came in through the audience?
Oh, yes. Looks like we got a couple more that just came in. Is RTF included with which licenses?
So your licensing works as your license is across all the form factors. You can have, let's say you have a platinum, you have, or a gold, or you have a titanium. So that's your licensing model with MuleSoft, but you can share your license with any of these form factors. It can be a Runtime Fabric, it can be a Cloud Hub. So you have the option to share your or split your license across Runtime Fabric and Cloud Hub and on-prem. So for that, you can still have a platinum, but you can, as I said, split your license. So you have to contact your MuleSoft Success Manager, and you can have a discussion with them to split your license between Runtime Fabric or your other environment. So you can do that. So it's the licensing is not based on where you're deploying, based on like the number of codes and the models you have selected with MuleSoft.
Oh, and then same person asked, so multi-environment.
Oh yeah, yeah. I mean, you can have different environments like dedicated for your Cloud Hub, some environment dedicated for Runtime Fabric. You can really go for a multi-environment across Runtime Fabric and Cloud Hub and on-prem too. But it has to be dedicated for Runtime Fabric. And you can also share environments across business groups. That's also a great feature of Runtime Fabric.
Okay, excellent. Another question we got in just now, since RTF is based on Docker and Kubernetes containerization infrastructure, can we deploy non-Mule applications to this containerization using RTF?
No, the answer is no.
As an example, a Java application packaged as jar.
Yeah, no, I mean, it's think of Runtime Fabric as a closed book kind of thing. So you only can deploy the Mule workloads, not the non-Mule workloads. So it has to be a Mule application deployed, not the Java, not the .NET, not like that. For that, you may have to switch to a different platform like Pivotal Cloud Foundry or OpenShift kind of thing, or other container platform as a service or a container as a service. You can that should be sitting next to the MuleSoft Runtime Fabric, but not inside.
Okay, excellent. Well, with that, I think it concludes our webinar today. Thank you so much to everyone who joined, and thank you to all of our panelists. Really great information today.
Absolutely.
All right, and have a great rest of your day, everyone.
Thanks, Alex.
Thank you.
Thanks, everybody.
Thanks.